And with that, we can get into the first session. So it's my great pleasure to introduce Rob Hyndman, who will be starting the event by giving a little bit of a retrospective tour of the forecasting software that he's worked on and that other people are now working on over the past 25 minutes. Thank you, Rob. Thank you, Rob. Not coming through yet. Okay. And I'm also.
Okay. Well, thanks, Mitch. And it is pretty exciting, actually, to have a lot of software developers interested in forecasting together in the room. So I've probably been at it longer than anyone here, so I thought I'd tell you some of the history of where things started and how it's developed over time. So I'm going to talk mostly about R because that was the language that was first used in open source development. And that's the one that I'm most familiar with because I've written a few R packages. I will talk a little bit about the lay of the land in Python and Julia as well, and then talk about open source data for forecasting and open source books for forecasting. So 25 years ago, year 2000 had just started using R. Actually, I was using other languages before that, but R had sort of begun to take off in the late 1990s. And so I started using it mostly for my consulting work. And at the time, there were 3 functions that did forecasting: the HoltWinters function, ARIMA, and StructTS, which all still exist in the stats package. At that time, they were in a package called TS. They were written, HoltWinters was written by David Meyer. The other 2 were written by Brian Ripley. All 3 produced output that was inconsistent with each other. So you couldn't just take the output and do the same thing with it. It was different structures and different types of things. And in the year 2000, ETS models didn't exist, and HoltWinters was just a point forecasting algorithm from the 1950s and 1960s. So they all had a predict method. So they're all predictors as a object-oriented class, a method in R, which works with different classes. So they all sort of used that, but the output was very different. So I was using these things in consulting and thought, it would be better if this was all a bit more consistent so I could switch models and try different things. So I needed a consistent output. So I introduced a new generic method called forecast and a new S3 class, object-oriented class called forecast as well. And then I started adding other methods as they developed. So at that stage in the year 2000, the big N3 forecasting competition had just taken place and the theta method had done well. So I thought, well, let's make the theta method available to other people, particularly since the paper that which described the theta method was almost opaque. Like nobody really understood what on earth these people were doing. And I spent a whole flight from Europe to Australia trying to understand that paper. And when I finally figured it out, I wrote a small function. Well, it's a very small function that actually does what the paper said I would do. And I thought, let's do some automation. So the ETS framework was just being developed. Like the ETS framework was done for a consulting project I did in about the year 2002. And so that went into the package. And ARIMA, of course, ARIMA was developed a few years later. And I wanted it so that you could try a different model on your data and you only have to change one small part of your code. So just change the model function, everything else should work. So I needed plotting tools. So I introduced a new method for plotting forecast objects and accuracy tools to compute accuracy statistics. So I introduced the accuracy method. So this was sort of the state of play for the first few years of this century. And I just did this for myself. Like I did stick the code on my website, but wasn't on Crown. And then I thought this was pretty useful. Someone else might like to use this stuff. So I went to the second user conference in 2006 and talked about this code base that I'd set up. And immediately they said, look, it should be on CRAN. So I went back to my hotel room after my talk and I wrote it up for a CRAN package and submitted it, and I got accepted pretty much the same day. Back in those days, it was easy to do CRAN submission. And there was only about 100 pages on CRAN, so it was, it wasn't the same world. And then I just started adding things to it over the next 15 years. So the first automated ARIMA algorithm was developed with a PhD student, Yasmin Kandikar. I put that in the package. Back in those days, packages came in bundles. So it's a concept that doesn't exist anymore. So at some point, it got unbundled from other packages. And then ARIMA, which is fractional modeling, and then I thought we need a whole lot of other things. So time series linear models and forecasting using STL decompositions, and then some benchmark methods like naive and S-naive, and added Box-Cox transformations and TBATs with another student. So all this stuff got added over time and took about 15 years. And I was doing about one major release a year for a while, up until around 2018. And by 2018, a notable event happened in 2015 when I had this young student in my class called Mitch, and he was really good. And so we started working together. And so Mitch came on board in version 7 and became basically the second developer. This up until then, it was entirely my work. So in end of 2015, he worked with me over summer and we produced version 7, and he added all the ggplot2 graphics and bias adjustment. And then in 2017, we added a bunch more stuff. And around then, he said, why don't we think about having a different interface? Because this is built on TS objects, which were really worked well for quarterly and monthly and annual data. But by this stage, we were thinking about hourly data or minute-by-minute data or weekly data, which that very simple object structure did not work well for. And although we tried to make the package handle those things, it was a shoehorn. It was a bit of a clutch to try to make it work rather than think about what type of objects would work best from the beginning. So I thought, and around 2017, 2018, we thought, well, let's just leave, I think it was 2018, let's just leave the forecast package as it is. We had so many users at that point that we couldn't possibly change them, do a major change. And let's start again. So from 2018 on, the idea was the package was just going to be in maintenance mode and keep it going, make sure bug fixes get work and make sure everyone can still use it, because I'd have a lot of users, but I wasn't going to add anything new. And so pretty well every year since then, there's been a few minor releases that's been version 8 point something right up to now. So just a little bit more about the package to point out some of the inconsistencies, which was just because when you develop software over 25 years, you're not going to, standards change and the way people use the software changes, and you're inevitably going to introduce inconsistencies, particularly when you have new things come along. So there's a bunch of modeling functions like order.arima, ETS, TBATs, BACS, ARIMA, NetAR, the neural nets, STLM, and they give you a model, and then you take that model and you pass it to the forecast function and it gives you forecast. So it's a very straightforward workflow. And there's another bunch of things which you give a data and it gives you a forecast, not giving you any model in the process. And so the second half of this list from mean F down is the functions that give you a forecast directly, sometimes because there isn't, like it's an algorithm that generates forecasts, there is no model. And sometimes because just the way it evolved at the time. But I've been convinced recently that I should do a final version 9, been one time since version 8, where we actually try to make this somewhat more consistent by adding modeling functions to the last few things here, so that everything works as visual model generates a forecast, but that'll definitely be the last version. I'll still maintain it, but that'll be it. So, okay, so that's sort of the history of the forecast package, which has been pretty influential because it was the only package for many years that did general forecasting, lots of different models. And a lot of the other developments in Python and in Julia have started with that and tried to modify some of it or all of it for use in other languages. So it really has sort of driven the way people have thought about forecasting software. At some stage, I started maintaining the CRAN task view for time series. So a CRAN is the network, the archive network for R packages, and task views are curated lists of packages for different topics. And so I ended up being the person that runs the time series one, and I've done that for more than 20 years. These days, Rebecca Killick helps me with that. So what I thought I'd do is I'd go to that list, which has every R package that we know of that we think is worth pointing out to people. Not that we've used them all, but they're all serious packages. And look at what are the ones that do forecasting. So I've pulled out all of the ones that do forecasting, and then I just got download statistics on all of them since they were introduced to find the top 10 forecasting packages. So I did it since the beginning of CRAN, but then I thought, well, that's a bit unfair to all the new packages. So I did it only for the last 5 years, and it made no difference whatever to the list. It's the same 10. There was 2 packages that switched the order, 5 and 6, I think it was, but otherwise it's the same list. So it doesn't matter whether it's the last 5 years or the last 25 years. And these numbers are in thousands. So the forecast package has been downloaded nearly 23 million times. It's a lot more than that because the download statistics are incomplete, but it's all the ones that get counted by RStudio or by POSIT. Number 2 on the list is StructTS, which is Bayesian structural time series. And then VARS, which does multivariate VAR models. And then Profit, which is a wrapper to the Profit from Facebook. The Smooth package, which comes out of Lancaster, that's Ivan Svetnikov's package, one of his packages. Fable Tools and Fable, which are developed at Monash with Mitch as the main developer. Greybox is another one by Ivan. And then HTS and Thief are 2 reconciliation packages that I started, still maintain one of them. So they're the top 10. Here's the download statistics on the 10. And you can see that forecast package, even though it really hasn't been developed much in the last 7 years or so, has still dominates a lot, which I think is sort of surprising because the Fable package was considerably better in my view. And but there's a lot of inertia here. People use what they know. And there's some weird things going on in the data. Don't know what happened at the end of 2015. Probably some script was downloading without that repeatedly or something. So let's get rid of the forecast package so we can see a bit more of the rest. And again, you get some weird thing happened to the BSTS package at one point. So it's pretty noisy, but you get an idea of what's going on. And we'll just focus on the last little bit. And you can see there that, there's not a lot of change, but one of the things that you do notice is that there's been a decline in pretty well all packages. If we go back to the original graph, even in the forecast package, it's declined quite a bit since start of 2024. And all of them have been declining since about 2022, which I guess is the rise of Python. But I can't got data to confirm that, but I would guess that's what's going on as Python gets used more in businesses and commercial settings in particular. So let me just pick up a couple of the, I didn't bring my phone up here, so I don't know what the time is, but could you pass me the phone, then I'll at least try to keep the time. Let me talk a little bit about some of the functions that implement similar models. So the original HoltWinters function implemented some types of exponential smoothing. Then the forecast function, the ETS function in the forecast package, I should mention it wasn't, I think I said it was only me, but it was Christoph, of course, who was helping with the ETS function in the forecast package and rewrote it at one point. So it was much faster. So that's the ETS function. And then there's the Fable version of the ETS function and the ES function in the smooth package, which are all doing something similar, although the smooth package does include covariates. What you might not know is that the not Christoph's version of the ETS function, but my original version of the ETS function has been used in other software. I mean, it's open source, but there's a GPL license, so commercial software can't just pick it up and use it. But at least 2 commercial packages have basically bought the code from me. So if you ever ask for a forecast in Tableau, it's using an old version of the C code that underpins the ETS function in R. So let's have a look at these 3. So in the forecast package, you take a TS object, and I'm just using the air passages data as an example. So you take a TS object, you pass it into ETS, it gives you an automatically chosen ETS model. And it's, thanks to Christoph, it's very fast. It still surprises me how fast it is, because it's fitting a lot of models with a lot of optimization, but it's incredibly fast. And then you take that and you pipe it into the forecast function, and it gives you back a forecast object, which when you print it to the screen looks like that, which has some point forecasts and 2 prediction intervals, 80% and 95%. You can change the prediction intervals, but it's only intervals, it's not whole distributions. The Fable package has a similar workflow in that you take the data, you have to convert it to its Sybil object, you pipe it into a modeling function, and then you can have a look at the model using the report function, and it looks pretty much identical because pretty much the same code. And you can also pipe it into the forecast function. The difference here is that, well, there's a couple of differences. One is, my screen is not showing the output properly, but you've got a distribution column, which is a normal distribution, and you've got a mean column, which is the mean of the distribution. So the fact that it gives you a whole distribution is quite important because this is now fully probabilistic forecasting. Secondly, the Fable package will fit models to lots of series simultaneously in the same code. This is only giving it 1 series, but you can give it 1,000 series and it try to fit models to all of them. And you can fit inside the model function, you can fit multiple models to each of the multiple series. So it is much, much better at handling large-scale forecasting problems. And then the smooth function also uses TS objects, and it has a different algorithm, so it produces different models, and its output looks like that. But again, you can pass it into the forecast function, and it'll give you output a little bit similar to the forecast package. Not the same, but somewhat similar. So that's sort of the 3 most widely used implementations of exponential smoothing in R. I thought I'd do some benchmarks. I'd never actually done this before. So I took the 3 models, gave it the same data set, and gave it the same number of forecasts to produce. And you can see that the forecast function is the fastest. The Fable package is not far behind, and the smooth package takes quite a bit longer in this example. More than about 2 to 3 times longer. Okay, what about ARIMA functions? So there's a little more choice in ARIMA functions. There's the original ARIMA code. There's forecast ARIMA, which just gives you the model you chose. It doesn't automatically choose one. There's forecast order.ARIMA, which does everything automatically. There's Fable ARIMA, which is almost the same algorithm as in order.ARIMA. And then there's 2 functions in the smooth package, one of which is automated and which is not. So let's see how these go. So same data set. I'm fitting to the log of the data. So order.arima gives you that. The classic, this model is called the airline model because it's the famous model for this particular data set in the original Box and Jenkins book. And you can get forecasts. The Fable package actually doesn't give you the airline model for the airline data. It gives you a different model because it has different choices in the how it handles the differencing, the choice of differencing. And you get forecasts. Well, you can see here the output a little better than you saw before. So the dist column actually contains distributions, and because I'm modeling the log of the data, it's a transformed normal distribution. It's actually log normal. And then the mean of that distribution, which does the bias adjustment on the fly, to think about. And then the smooth package gives you a different model again. Again, not the famous airline model, and it's got 6 parameters where the other 2 models didn't have so many parameters. I'm not sure why it's choosing that model. It doesn't seem to me to be the best model, but maybe there's a good reason. And benchmarks. Now this is interesting. The benchmarks, the forecast package, again, it's the fastest and uses the least memory. The Fable package is by far the slowest. And the reason for that is that in the process of fitting all of the possible models, it keeps all of the models in memory. So it fits a lot of different models and retains a lot of that in memory before it chooses one. And so it ends up using a lot more memory, 1.2 gigabytes instead of 400 megabytes. So that's something that Mitch and I probably need to look at to see if we can make that a little faster. You don't think so?
It also considers more models.
It does consider more models, but I think the
memory could be reworked.
Yes. Yeah. It looks further afield than the forecast package, which only looks very close in 5 models.
I think especially once we've found one better, we can discard the old ones.
Yeah. I think the memory allocation issue will actually speed it up a lot. I don't think the speed is to do with it so much looking at more models. I think it's more that it's struggling to deal with all the memory. Okay, let's turn to reconciliation packages. So the first one was the HTS package, which has been written so many times, and it's a little bit ugly because of the way it evolved. But at the moment, Shanika did contribute to it for a while. The moment Eero Wan maintains it, but it's not in development at all, just bug fixing. The Thief package was designed for temporal reconciliation. The Fable package is intended to do it all eventually, but at the moment just does cross-sectional. But it does do probabilistic because that's the nature of Fable. And that's where most of our development's going to be. Eventually, we hope people do all things on this list. And Daniela Giulometo's Foreco package, where's Daniela up the back? It's the only package that does everything at the moment. I think its user interface is a little hard sometimes to navigate, but it does do everything and does it well. Okay, so that's sort of the state of play in the R world, or the main packages that get used in the R world. Let me turn to Python, and as I said, I'm much less of an expert on Python. I have not developed any Python packages myself. But I went looking to see what was out there and what people used. The Python packages are largely divided into ones that implement statistical models and ones that implement things that are traditionally thought of as machine learning models. So I've skipped them in the same way. So Python packages that basically try to do some of what the forecast package and the Fable package does. Stats models, which does a lot more. That does all sorts of statistical models. It's a big package, a lot of stuff in it. The first attempt to port my order.arima function into R was PMD ARIMA. I would not recommend you use that. That's not a particularly good port. It does the job, and because it was first, it's still widely used, but there are better options. SK Time came along in 2019. So the dates on here are the first release date and the most recent release date. that I could find on GitHub. SKTime came along and it tries to do a lot of things. It does include a wrapper to P&D ARIMA and to some of the stats forecast functions from Nixler. Gluon from Amazon does some things, but often via a wrapper to the R forecast package. So it's calling R code, I think, when it does that. The Dubs, again, wraps stats forecast. Merlion from Salesforce seems not to be developed anymore. Stats forecast is probably the one under most active development from Nixler. And as you can see, other packages are now wrapping it because it does do some really good implementations, particularly of the order.arima and ETS algorithms. And then new one on the block is Eon, which Tony's here, who's one of the lead developers there. It was a fork of SKTime, but it's heading off in its own direction. So there's lots of activity, but particularly in the last maybe 5 or 6 years. I tried to get some downloads on these. PyPyStats gives you some downloads from people that get up via PyPy. It's a little hard to access data that's older than about 6 months. It is on BigQuery, but I couldn't get BigQuery to give me any data. It kept telling me I was overquoted, or even I was asking for tiny amounts of data. So I just got 6 months. And you can see stats models totally dominates here, but that's not surprising because it does much more than forecasting a time series. So let's remove that and we'll see the rest. So you can see, I'm also removing P&D ARIMA, which is the red line there. If you look at other than those two, you can see GluonTS is actually the one that's developing in terms of downloads, the fastest. And stats forecast there in purple and SKTime in green. They're the 3 big ones in this space. And then the others are trotting along down the bottom to see how any of those will change over time. I haven't got profit here. I've got neural profit, but I haven't got profit itself. But that'll be huge, largely because Facebook somehow convinced everyone it was good. But it's not. The most complete stats packages, so this is only the statistical parts of these packages that I can see, is stats models, which does a little bit of forecasting, but it's actually not particularly well developed really, because nothing's automated. So you can fit an ARIMA model or an ETS model, but you can't automatically choose one. It does do some other things like MSTL and theta. It looks to me like, I don't know who wrote these things, but it looks to me like someone with an econometrics background from about 25 years ago. Like it really doesn't look like they've kept up with what's going on in forecasting. SKTime does a lot of stuff. It basically has taken all of the stuff in the forecast package and ported it over to Python. I don't know whether it's rewritten or how much of it support, but it does at least those ones, as well as a lot of machine learning things. And then the Nixler package, again, started with the forecast package, and a lot of what you see in Nixler, you can see where it's come from in that space, but it's also done other things like Arch and Garch and Data and things that are certainly not in any of the packages I've developed. And then you've got all the machine learning ones. Again, some of the same names here, but some few other ones. You can see the list. So a couple of the SK forecast and PyTorch forecasting are some of the more recent ones that are under pretty active development. Nixler, of course, is very active in lots of ways. So ML forecast and neural forecast, both here on this list. Some of the early stuff seems to have stopped. So CATS and Merlion, I don't think have been developed at all. So I just picked the ones that seem to be the most, a couple of the ones that are the biggest. I'm not saying these are necessarily doing more than everyone else, but just to give you a flavor, there's a lot of things in GluonTS. Maybe our Amazon person might talk about this later, I don't know. But there's a lot of stuff going on in GluonTS with lots of different types of neural nets and deep learning. transformer models, and so on. And there's a lot of things going on in neural forecast from Nixler. Some of the same things, some different things. But there's loads and loads of implementations of different models here. In the reconciliation space, I think there are only these four, although obviously in this audience you may know other things and please feel free to add them. But in the reconciliation space, SK time of the first, then darts and HoltWinters from Bohan, who's here somewhere, which I don't think has been developed anymore. I couldn't see anything after 2022. But maybe you're doing another one that I don't know about. And then hierarchical forecast from Nixler. And none of these do everything. The only one that does temporal reconciliation is Bohan's HoltWinters package. And the only one that does anything probabilistic is Nixler's hierarchical forecast package. Nixler does everything. Nixler does everything now? Okay. Okay. I'll have to update this.
We released for Python too.
Okay. Thank you for that correction. Now turning to foundation models, which I have even less expertise in, but I found, well, I'll tell you a little bit in a minute about the Python edition of the book that we've worked on, but these are the ones listed in the book. It's hard to say what's open source and what's not with foundation models because a lot of us, parts of it are open source and parts of it are not. The only one I think is probably fully open source is Lag Llama, but I could be wrong. But there's a bunch of those here. And I'm running out of time, so let me just quickly go through some other stuff. Julia, there's been much less development and every package I've seen is quite limited in what it tries to cover. I haven't seen a single package that tries to do Jamble forecasting. I'm hoping that we'll hear about some developments in that space later on, but these are the ones I could find, and some of them no longer work. Some of them are quite limited in what they do. Nothing I would look at and say that looks like a drop-in replacement for anything that's similar to what's going on in the Python and R world yet. Let me talk about data. So Christoph and I and some others set up forecastingdata.org, which contains an enormous amount of data that has been used in forecasting competitions and in forecasting comparisons. And much of the work on foundation models has been built on this data set, or parts of this data set. So if you don't know about it, it is all open source and you can access it pretty easily from R and Python. I don't think there's a Julia, anything in Julia to pull it down, but it would be easy to write. It's very straightforward. And then lastly, I wanted to talk about books. So in the open source books, I mean, so this is an open source forecasting workshop, so I'm only talking about books that are completely open. So the forecasting principles and practice that I wrote with George first in 2013, the blue version uses the forecast package, the red version uses the Fable package, and the black version uses Python's Nixler packages from Python. So the black one's brand new, only came out a month or two ago, and it's online. You can see all of these at otex.com. The first two are also available in print. The Python one will be available in print as soon as I can do all of the translation into LaTeX, so we can get a good PDF version. So I'm working on that at the moment, and hopefully by the end of the year, that will also be available in print. And you can see there's a bunch of new authors on the Python book, all of which have had some connection with Nixler, although they don't all work there now. I also wanted to point out that Ivan also has an open access textbook, which is published with CRC Press, that the open version is at bobanforecast.org. And lastly, just let me finish by giving you a link to the slides, and every package that I've talked about, I've put a link on that website. So just go robjhyndman.com/OSFS25. That's Open Source Forecasting Software 2025. And all the Python packages, Julia packages, everything that I could find new still I stuck there. And there's a postdoc going in forecast reconciliation at Monash. So if you're finishing a PhD and want to do a postdoc, go to that link and apply for the job. Thank you. Questions? Yep.
So over all these years, what I noticed, for example, I also make the for us, and there's like new models every day, and then users saying like, this new model is definitely state of the art, and Fiduci isn't, but implement this. How do you, like, over the years, sort of like filter the signal from the noise in terms of the hype? And because there must have been hype, right? I think over the years.
That's a good question. I've mostly only put, well, first to start with, I put in things that I wanted to use myself. And then I put in stuff that I was developing because I wanted other people to be able to use my things. So that was my first motivation. And then over time, I will put in models if they've sort of proven themselves. So the theta method won a competition, so it's clearly good. But I will not put in models just because someone says this is the latest, greatest thing, because it needs some demonstration of that. And there's, particularly in machine learning, there's ridiculous amounts of hype about methods and claims that are completely untrue. They'll do pathetic evaluations that show that their method is better. But if you look at the data they're using or the way they're doing the evaluation, it's just unvalid. So I'm extremely skeptical about a lot of stuff. I don't know whether Christoph's going to give his talk. No, Christoph has a great talk. I'm sure it's on YouTube. Great talk on YouTube. Look it up, about some of the claims and thinking about how to evaluate some of these things. So, yeah. So I mean, I'm not trying to sort of put everything in, anything I write, and trying to put in stuff that I think is useful, but that I think people should use. And to some extent, once you put it in a package that's well used, you're basically telling people this is good stuff. And I am reluctant to do that unless I really do think that's true. But I have a different motivation from some other software developers who just want to make sure everyone has access to everything. And that's a very different motivation from the way I kind of write software. Yeah.
Thanks for the talk. I want to ask maybe a difference between the statistical model and the machine learning approach for forecasting. Do you have a view on how much are they being used in the business cases, and mainly all like the more and more scalability than it's maybe nowadays with 1,000 series that is important? You have some view on that?
Yeah, I mean, there's a different philosophy around statistical modeling and the way machine learners approach models. So a statistical modeler usually thinks in terms of a set of equations with a driving stochastic process. And so you end up with this implicitly stochastic model that you can then run forward in time to get possible futures, and your forecast is based on those possible futures. Whereas a machine learning model doesn't sort of think in terms of stochastic error tones. It's an algorithm which generates some future number. And you can compute the error by looking at how well it did on past data, but there's no driving stochastic process. It's a very different thing. And it's quite hard to write software that does both in a similar interface because of that difference. So I have it's a bit of a toy neural net model, but in the forecast package, there's this net-arth process, and I wanted to have just prediction intervals, but there is no prediction interval, but naturally comes out of that model. So I sort of implemented a way of simulating future sample paths based on past errors, and it does it that way, but it's not implicit in the way the model's developed.
Anyway, and are you seeing like that it's feasible, like to scale in a business case where like several thousand of them series or close to million them series, that the statistical model approach, it's possible?
Absolutely possible, and people have been doing it for a long time because they're all completely parallelizable. If you've got a million series, you're not fitting models that try to model a relationship between series. You're treating them all as univariate series usually. And so it's completely parallelizable. So yeah, companies have been doing that for years. And it works fine. And it's pretty hard to beat. If you take 2 or 3 half-decent statistical models, even 2, like an ARIMA model and an ETS model, and you average them, it's very hard to beat that forecast for most real data, even with some fancy new thing off, that everyone says this is the latest, greatest. I would say, well, compare it against the average of an ETS and an ARIMA model, and does it do better? If it does better, fine. We'll look at doing that, but mostly it doesn't. So yeah, scalability, I don't, because of you can parallelize things. I don't think scalability is a big issue with these models.
I will take one last question from online. I think Azul has a question.
Hi, Azul.
No, can you type it? Sorry. We'll come back to you.
Maybe one follow-up question. So I think what you say is obviously true for monthly data, but and column and stuff like this, if hourly data, do you think that's better or ARIMA DTS?
No. So okay, once you get down to higher frequency data, then those 2 modeling frameworks are not designed to deal with that. But there are other models that work fine. TVATS is an interesting example because it's not very well implemented. And it's very slow, and the code is ugly, and I didn't write it, but it's not good. And I know it's been rewritten by a couple of other people, and I don't know, I haven't looked at their code, and I haven't run it, so I don't know how good it is. But I'm sure it will be better than the TVATS that's in the forecast package, which was, I would not, it works well, but it's slow and ugly.
Okay, Azul, we'll try one more time. Otherwise, we have to ask during the break somehow. Hello, we'll run it from here. Yes, we're here.
Nice. Thank you so much for the presentation, Rob. Very interesting. And I would like to hear your thoughts around the future of open source forecasting software. What do you think is missing in the space? What do you think it's next? What's the next big thing in the forecasting the space? Speaking from an open source software.
That's a good question, Azul. It's the sort of question I might ask you. So it's a little hard for me to answer. Like standing here 25 years after I first started doing this stuff, and I think I was the only person in the world writing open source forecasting software, the only one I knew about anyway. And to have a whole workshop on it is really exciting to me. So the space has changed a lot, and a lot more languages. And yeah, I would hope that people would. But I'm not going to give a forecast about how forecasting software is going to develop, because I don't think I am capable of doing that. What I'd like to see happen is more concentration on nicer user interfaces and easier implementation of models for people in practice. Like, it is a bit difficult to use some of the open source software because the design interfaces I don't think have been thought through very well. And I'd like to see more work done on outside of the R and Python space, because I think both languages have limitations. I'm excited to hear about Julia, and I think that there's space for also doing some work in other languages. Even low-level things like there is open source C++ code now for ARIMA and ETS that you can pick up and use, and it works pretty well. But there's not much other open source low-level stuff that is easy for people to pick up and plug into their own software, and I'd like to see that happen as well.
Okay, thank you, Rob.